I'm Anton. I am one of the two co-founders of Chroma. My co-founder, Jeff, was originally going to do this presentation, but he's got a wife and children at home, and I don't, so here I am. You get me instead. So I want to talk about what we're building in Chroma and what we think of as programmable memory for AI, what that actually means. But let's start with the basics. So by now, most people in this audience, and I'm guessing most people who will view the recording, will have seen some version of this sort of retrieval augmented generation, this sort of document-based question answering. But just to recap about how that actually works is you take some documents, you use an embedding model to embed them using Chroma. You have a query, you take your query and embed it. We retrieve the documents relevant to that query. You pass both the query and those documents to your large language model, in this case, OpenAI, and the model returns an answer, right? And that's a very typical loop, and this is actually extremely powerful. It's a nonlinear way of interacting conversationally with text. So I don't mean actually to reduce the importance of this particular use case, and it's definitely the number one thing people are building today with an embedding retrieval system like Chroma. But what I want to talk about is actually, and you can try us. We're pretty good. You should try it. It is open source. It is not free. It costs 1 GitHub star to use. Now, so is that it? Is that all we can do? Well, right now, even though it's the main use case, and like I said, it is very powerful, there's a lot more that we can do. And we're seeing some of these new use cases emerge. And these are the things that I'm most excited about. So again, just to recap, what we have now is what I think of as open loop. Open loop means that you have an input, an output comes out, and you do nothing with it. You basically respond to the query, and it's completely stateless. Now, the next augmentation of that, and we're starting to see some of this come online, is basically rather than just sending the answer out, you can also have a human review that answer and then store the outcome of that answer in Chroma or in your embedding store in order for it to be reused later to improve the output of those queries. This is already another step forward beyond the open loop system, because you're turning your static, flat knowledge base into a data engine that's powered by humans augmenting the responses of the model and basically giving you signal about whether those responses are any good or not. And again, fairly straightforward. The most common way that this is actually implemented is in, for example, a customer support system where you will have a support agent actually review the answers that the model gave at some point and then rank them or rewrite them or compose new documentation on that basis, right? It allows you to constantly improves the information available to your users and to the model itself. So it's quite nice. But where things are really going are these fully autonomous systems. And by now we've seen, we heard Jerry and a few others talk about agents earlier. I'd like to just go into what that actually means in practice. What we have in the most basic agent closed loop system now, and this is a system which can actually feed back into itself, is a way for the model to learn something from its own actions and its own thoughts. And one example use case of that uses Chroma in the wild today is a thing called Baby AGI, and this is a video that's going to play because I couldn't trust that the OpenAI API would be available today. We've all had that happen to us, right? So Baby AGI is kind of great. As the name says, it's an attempt to build a general purpose agentic system. Right now, it's basically a toy, but a lot of great technologies start off as toys. And part of the reason why I'm so bullish on these things is because they're toys that anybody can pick up and experiment with. And what it does is you give it a task at the start, and it generates a task list on the basis of that task, but it then stores what it decides to do on the basis of each task back into its knowledge base, generates new tasks, and nominally works towards solving the original problem that you gave it. Now, in this case, I asked it to come up with a demo for Stripe AI Demo Day, but it assumed I was a Stripe employee. It did, however, correctly guess that it would be something to do with fraud detection, so bonus points to ChatGPT there. So it's the first type of closed loop system that you can run when you have programmable memory for AI. Now, the next type, and this is even, as we go up this ladder, things get more experimental but more interesting as well, is you provide the agent with a world model that it can interact with. So in the previous type of system, you have a agent that is basically just thinking. It's interacting only with itself. Here, you can use a world model to actually ground the actions and the thoughts that the agent has with some real world feedback. In other words, it allows the agent to test its thoughts or approach or the task that it's performing against some actual model of the world. So what that looks like concretely is a little project that I made a few weeks ago. This is a theorem prover. It uses GPT plus the software proof assistant known as Coq. I'm actually replacing that with Lean later this weekend, only of interest to math nerds in the audience, but I know there's a few of you. And what this guy does is I ask it to prove a mathematical theorem. It decomposes the theorem into component parts. It comes up with natural language proofs for each of those components, and then a different piece of the model translates those proofs into software code that then I can execute in the external software environment, which is a formal mathematical theorem prover. It allows it to check whether or not its approach to solving this theorem is actually correct. When it actually succeeds in solving one of those subconjectures, I store the natural language description of that proof, like what the proof is for and the approach that it was taken, alongside the software code that was generated in the knowledge base. And that allows it to build up more and more complex systems of mathematical proof. It allows the agent to sort of explore proof space fairly autonomously. Now, this isn't perfect. It breaks a lot because I built this mainly as a weekend hack, but it does show a lot of promise. And there's a lot of different versions of this. And here it actually did manage to prove the commutativity of addition of the natural numbers eventually under Peano axioms. And this idea of grounding agents with feedback from the world while you have this programmable memory in order for them to remember their interactions is also very powerful, and I imagine will be generally useful in the future. And then finally, we can tie all of these things together. So we've talked about human feedback. We've talked about closed loops with agents interacting with themselves and interacting with the world. We can also build, in the same way that we can build these sort of question-answer systems and engage human feedback on top of the answers that the models give, we can also give human feedback on top of the actions that these agents take when they're given access to a world model. And so the most recent, and this is not Chroma's research, but it is something built with Chroma, is the Voyager Minecraft playing bot, which essentially learns to play Minecraft from scratch. And the way that it uses the programmable memory system that Chroma provides is by storing relevant skills and how it performs tasks in particular situations, so that when it encounters those situations again, or when it faces the same objective, it knows what to do. Now, where the human feedback comes into this is it can also learn from what human players do in similar situations by asking for humans or looking for similar situations that humans have performed actions in a game of Minecraft and learn from them as well. So you have a complete holistic agentic learning system. Now, none of these are especially useful today, but as I mentioned, they are easy and they are toys. And like in the early days of the web, this huge explosion of creativity you can have by having simple tools that are easy to install and just kind of run with, along with the natural language ability to actually interact with these systems, because again, they're built on large language models, gives you enormous power, enormous creativity. So I'm extremely bullish on this overall direction for programmable memory for AI, and Chroma will continue to power it into the future. Yeah. I'll take questions, but only if they're interesting.
Yeah, so this idea of using a world model is very interesting, but it's extremely easy when you have something as well-defined as mathematical reasoning. How do you apply that to something more complex that's not so well-defined?
Yeah, that's a really open research question, right? And this is kind of fundamental to a lot of the things that we build in general as autonomous agents, autonomous machines. What is the action space that we have available, right? I actually specifically chose mathematics, one, because it's a personal interest, but another is because, as you said, it's extremely well-defined. And we've seen game-playing agents for some time now, right? We've seen AlphaGo, we've seen basically the self-play series. They have a very well-defined action space. I think one thing that the current crop of language models provide us is the fact that they are generally applicable to a wide range of world models, because language is this general purpose system, right? So I think that even in less well-defined environments, so long as the model is representing with sufficient fidelity the interesting parts of the world for the actions you're trying to perform, you can make progress in this direction.
Why? Yeah, have you thought about applying this to programming? Because that's relatively well-defined.
Yeah, so there are a lot of efforts right now to build autonomous programmers. It's obviously one of those things that's enormously economically valuable, so naturally people will try to build this. We have things like the function calling API, and there's a few other extensions to OpenAI's LLMs and other LLMs where they have access to a programming environment. And in fact, we've seen that it improves the mathematical reasoning of the models. If you, instead of asking them to solve a mathematical problem, you say, write a Python program to get the answer and then execute that and then iterate on that approach. So I think that programming is definitely one of those approaches. And programming is one of these nice things because computers and programming are one of the main ways that humans interface with controlling the world at this point, and that's only going to grow. So it makes sense.
Hi, thank you so much. I want to get a sense from you, what is the value that Chroma adds in this loop? Because one could argue, like, how much benefit does Chroma add to get these tasks to work? My background is reinforcement learning. So can I do these just with reinforcement learning and some, access to a model that gives me the embeddings directly within the whole architecture? Like, I just want to get a sense. What do you think Chroma adds to the performance of achieving these tasks?
Multi-layered question. So first of all, the utility of Chroma itself as a software package is it makes it easy to interact with retrieval, either in a research context or in a product development context. This model here, actually, we didn't support the research team at all. They picked up Chroma because it was the right thing for the retrieval subsystem of this agent. It retrieves the skills necessary to do these actions, right? It's an embedding-based retrieval system. So we provide basically the nearest neighbor search, we provide the embedding functions, everything is built in. So all you have to do is think about the functionality of your agent rather than how am I going to store these things? How am I going to make sure I'm retrieving them in an efficient way? Which, do I have to call the embedding function every time? All of that storage and management, we handle that for you. Now, from the perspective of the second implicit question there, which was, how do I think about learning versus retrieval, right? Because earlier we had this discussion of fine-tuning. And so the intuition that, I've developed, and I think a lot of researchers in this space have developed over the recent months and years, is that fine-tuning is great for conditioning the distribution of behaviors. Or in another way, and people are definitely going to yell at me for this analogy, but you can think of it as a form of style transfer for behavior or output of a particular model. In this sense, learning is quite useful, but it's also more expensive, and it doesn't guarantee that any particular fact or knowledge is going to be updated or remembered, right? Yes. Yes. Something like that. It's an easy way to store knowledge in natural language for use with an AI system. And one of the things that we really are focused on is making this as simple and easy as possible to adopt, because we're in an age of enormous experimentation. Like I said earlier, this document-based, question-answer, retrieval-based question answering systems are very powerful, but there's no way it's the most powerful thing we're going to see out of AI. And one of the greatest things that we can do as a company, as an organization, is make it easy for you and everybody else to explore the full space of what's possible. So I was particularly proud that this research used us, because it means we're building the right thing. Sorry, I forgot the part where I'm supposed to call him.
Thank you. So my question is, as we are seeing more LMs getting bigger context windows, 100K, 5 million context tokens, do you think the role for VectorDB as memory is being squeezed?
I actually think that longer context is fantastic for retrieval-based systems from two perspectives. One, the biggest limitation of what we can do with the retrieval augmented generation currently is the fact that context windows are too small. We haven't been able to fit all the information necessary into them. And so people have had to focus too much on how do they chunk up their information, how do they store it hierarchically, how do we make sure it's available to the model, right? So larger contexts are actually better for that. We can put more relevant information into the context. Now, the second piece is just because you have a longer context doesn't mean that relevancy suddenly becomes unimportant, right? There's very good empirical results actually just recently which demonstrate that model architectures with longer context windows can't necessarily attend to every token in that context window equally in order to perform a particular task. And specifically, in sort of boiling down what I'm saying, distractors in the context window are really bad for model performance on particular tasks. Relevancy is also important. And that's the other thing that a retrieval system does for you. It retrieves the relevant information.
So I think what you're saying is people not necessarily have to use all that 5 million or billion token length of context window. They will still want to use VectorDB to distill the relevance.
Correct. Not just that, and the thing is that it's often a misnomer to think of us as a VectorDB. Vector storage is how we achieve the thing we're doing for you, which is basically finding relevant information for your model to perform the task. If there's some other way to do it, and in future I believe there will be, And one of the ways that I think it will be is by actually coupling the attention mechanism in the model directly into the retrieval step. And we've seen that with memorizing transformer, with unlimiformer. I think there's going to be a lot of room to feed tokens to the model directly instead of taking this sort of embed, retrieve, embed loop, which we do currently. Yeah.
Thank you.
You need to let me know when I should stop. I could keep doing this for a while. All right, this is the last one.
So, recently folks like, Andrei Karpathy said that agents might be like L5 self-driving, which, took a while to get to actually real world applications. But like folks like Tesla in the past have just like slowly rolled it out, but it's actually useful when it's not L5. I'm curious if you have any predictions for agents and if they will achieve some sort of like enterprise or consumer usefulness before that whole like L5 self-driving phase.
Yeah, I think so. That's a really great question. And I actually worked in the self-driving space for a number of years. So it felt very much how long it takes to get to a real capability in a deployed system because the world is so complex. I think my answer to this question is, unlike self-driving, where you need to be able to drive in all conditions at all times to really be an economically viable system, an agent can have a small, tight, localized thing that it performs very, very well to be economically useful, and the cost of developing and deploying such an agent is so much lower than the upfront capital and R&D costs of deploying something like a self-driving car. Personally, I can imagine a specific application that I want for an agent today, which is a little homunculus, which lives in my email inbox, and the things that I don't really need to use any brain power, like scheduling a meeting or, just replying about the current status of some project, which I don't actually have to think about, is purely information exchange. I think that could be built today, and that would be enormously valuable to me, for example. And then it should just ask me when it doesn't know what to do, right? I think that's buildable today without going to a fully general purpose AGI system. So I both agree with Andre, but I also, I feel like this is a much more tightly scoped problem where there's salami slices that we can cut off of it, which are going to be individually useful as we build our way up to that fully general agent. Yeah. All right, well, they're going to make me stop, so thank you, everybody. I hope you enjoyed that.